Today we are going to talk about the volume of a cylinder. Now we know from past experience that we have prisms, and here's a variety of prisms. And a prism has identical bases of the same polygon, and they run parallel. So you can see this is an equilateral triangle. There's a matching equilateral triangle here. However, the remaining faces are all rectangles. So that's what defines a prism. This particular prism has two bases of rectangles. This one has two bases of hexagons. So this is a hexagonal prism, a rectangular prism, and a triangular prism. And we said these are prisms because they're made up of polygons. They're also prisms because the lateral faces, or the faces that join the bases, are rectangles. So what happens if you have one big rectangle making a circle? So your base is a circle. It's in the same family as far as characteristics are concerned, but because it's not made of polygons, it's not called a prism. This is a cylinder. So we're going to be looking at the volume of a cylinder. But like a prism, we have two identical bases. In this case, we have two circles. And in this prism, again, we have two hexagons. So a cylinder is the same as a prism in that we have two bases that are identical, but specifically circles, and the remaining surface is a rectangle. Like a prism, it's a rectangle, but unlike a prism, the prism has multiple rectangles. The circle would just have one big rectangle. Anytime your prism or cylinder stands upright, in meaning that the lateral face, the rectangle, is running perpendicular to the bases, it is called a right cylinder. So or right prism or right pyramid, however we're going to talk about it. But we're going to talk about right cylinders. So I'm going to take this one away. So how do we figure out what the volume of a cylinder is? Remember that the volume of a cylinder is or has the same characteristics as a prism. So we're going to start with the volume formula for a prism. The volume formula for a prism is the area of the base, so the base area, times the height. But in the case of a cylinder, that base does not change. It is always going to be a circle. So we're going to replace our b with the area of a circle, which is pi times radius squared. And then because we want it to be volume, we're going to multiply by height. So height of the cylinder is just like height of a prism. But we call them h for the same thing. And it's the distance from one base to the next. So if you look at our example number 1 here, we have a cylinder with a circular base. I know it looks like an oval, but remember that we never get to look at anything straight down or straight on because we wouldn't be able to see all of its aspects. So it is at a slight tilt when we look at it, so our circle ends up looking like an oval. So the volume of a cylinder is the area of the circular base times the height. Now this is a diameter, which means we're going to have to cut it in half to get a radius of 4. So we're going to have pi times 4 squared times our height, which is 13. So we talked about this in a previous lesson when dealing with pi, with circles, that you can either use the pi key or you can type in 3.14. Now 3.14 is not as accurate as pi, because pi, the button, is 3.141592654, or at least that's what we can see. It continues to calculate. So this is a more accurate answer, and this is the one we want to use. So I'm going to take pi, using the pi button, and I'm going to multiply it by 4 squared. So you can see that I'm using the squared button, times 13, and I'm going to get approximately 653.5. I know normally we round to the hundredths place, but to make your life a little easier when it comes to filling in the answers online, we're going to go to the tenths place. So 653.5, and because it is volume, we are going to call it feet cubed. Number 2, volume is the area of the circular base times the height. Now you can see the circle isn't standing up this time. The circle is laying down. It doesn't change the concept. We're still going to look at it as a slight angle. So even though it does look like an oval, it's actually a circle. And so we can see all of this side, but we can't see all of this, but it's still a circle. So the radius is given as 12, so this is your radius. And we're going to square that, and then our height is from circle to circle, which is 15. A great example of where height does not necessarily mean up and down, just like base does not necessarily mean bottom. So we're going to use our calculator, and we're going to do pi times 12 squared times 15, and we're going to get 6,785.8 millimeters cubed. Now what if you don't have the pi button? What if you're having to use 3.14? In the first example, 3.14 gives you 653.1 feet cubed, and in the second example it gives you 6,782.4 millimeters cubed. So they are slightly different, but that's okay. And when you're entering your score or entering your answers on the online page, either one of the answers will be found acceptable. Remember that you do not have to enter the label feet cubed or millimeters cubed.